Okay guys, here's a quick video for you to figure out the differences between one solution, no solution, and infinitely many solutions when solving an equation. This first example is going to be for one solution, so we're going to start right away in solving this equation. So the first step is to look for any distributive property. There are no parentheses, so we're going to move on to the next step, which is combine like terms if they're on the same side of the equation. I have no like terms on the same side of the equation. Then we're to get the variable on the same side. Well, we only have one variable, and so it's only on one side of the equation. Now our next step is just to get the variable by itself. So we need to get rid of the things that are with the variable on that side of the equation. So we need to get rid of the 3, and we need to get rid of the coefficient of 4. So we're going to save this for last. So let's get rid of the 3. So we're going to subtract 3 on both sides. We'll end up with 4x equals 12. We're going to then get rid of the coefficient by dividing. Divide both sides by 4, and we'll end up with x equals 3. Now this means that the number 3 is the only value that we can plug in for x and make this equation true. This equation is saying that 3 plus 4x is the same as 15. So this has to equal 15. 3 is the only number we can plug in. 3 times 4 is 12. 12 plus 3 is 15. 15 equals 15. And that's what makes it one solution. There's no other numbers that will work. Okay, now this next one is going to result in a no solution. So let's go through those steps again. The first step is to see if there's any distributive property, which I see right on this side that there is. So we're going to do that first. So we need to distribute the 5 to everything inside the parentheses. 5 times x is 5x. 5 times negative 4 is negative 20. We didn't do anything to the right side of the equation, so we just rewrite it. Now our next step is to combine like terms if they're on the same side of the equation. We do have like terms, but they're not on the same side. So we go to the next step. Get the variable on the same side. So we need to get rid of this 5x and move it over here, or get rid of this 5x and move it over here. It doesn't matter which one you choose. So I'm going to subtract this one on this side and then subtract it over here. Notice that they are going to equal 0 and cancel out. This means that since our variable has disappeared, we have a special solution. So we rewrite what's still in our equation. 3 equals negative 20. Our job here is to figure out if the sentence written here is true. Does 3 equal negative 20? No. That is why this would be called a no solution. This means that in our original equation, there's no value, no number that we can put in for x and make this equation true. Now I'm going to use this part of our equation to test it. So if I write 5x plus 3 equals 5x minus 20, I can clearly see that nothing will balance this equation. This side and this side has the exact same number in it. But the left side is adding 3 to that number, so it's making it 3 larger. On this side, they're subtracting 20 from the exact same number. So this side, the number will become smaller. So there's no way that these can be equal to each other. This left side will never equal the right side, no matter what we put in for x. This side will always be smaller, and that's why they will never equal each other, and there's never going to be a solution to make it true. Okay, now the last example is going to result in infinitely many solutions. So let's see how that one works. Again, we're going to go through our steps. Is there any distributive property? There is on this side, so we need to do that first. So this 1/3 is going to get distributed to everything inside the parentheses. Well, 1/3 times 6 is the same thing as 1/3 times 6 over 1. That will result in 6 over 3 when we multiply the numerators and multiply the denominators, and 6 over 3 equals 2. So that results in a 2x. 1/3 times 3 is the same as 1/3 times 3 over 1, which results in 3 over 3, which is 1. The right side we didn't mess with, so we're going to just rewrite it. Now you can clearly see that we have the same thing written on both sides. So let's see what happens after that. The next step is to combine like terms if they're on the same side of the equation. Well, we do have like terms, but they're not on the same side. The next step is get variable on the same side. So we need to get rid of the 2x and move it over here, or get rid of this 2x and move it over here. It doesn't matter which one. So as you can see, the 2x's are going to cancel out because they equal 0. So we automatically know, since our variable disappeared, we're in a special solution. So we rewrite what is still in our equation, and we have 1 equals 1. Our job is to figure out, is that a true statement? 1 does equal 1. That's true. That tells us the answer is going to be infinitely many solutions. Well, let's see what that means. Do you remember up here that we had the same thing on both sides? Well, let's test that out. 2x plus 1 equals 2x plus 1. You can see that no matter what number I put in for x, this left side of the equation will always equal the right because they have the exact same equations in it. So I could pick a 2 for this x. 2 times 2 is 4. 4 plus 1 is 5. 2 times 2 is 4. 4 plus 1 is 5. We'll get 5 equals 5. But that's not the only number I can put in for x to make this true. What if I put 1,000,000 in for x? 1,000,000 times 2 is 2,000,000, plus 1 is 2,000,001. 1,000,000 times 2 is 2,000,000, plus 1 is 2,000,001. So no matter what value, I can put negatives, fractions, no matter what number I put in for x, this will always be a balanced equation. That's why it's infinitely many solutions. I hope that helps.